Hi guys, good morning. Can you hear me?
Yes, sir.
Hello.
Good morning. Here, yes.
Yeah, let us start session. Yeah, yesterday session, the basics started. So these basics, like system software, application software, is completed. Java is application software. Next, about OS also we have discussed. OS is a platform. Okay, like a OS is like a platform. On top of it, we can run all the application softwares, right? So Java is application software. Java is application software. Yes, sir. In application software, we have the front end, back end. There are two things like front end, back end. So in front end, back end softwares, Java comes under back end software. Here, Java is here, right? Java is a back end. Java is a back end software. Next, we have apart from the language and package, Java is a language. In languages, low level and high level language. Java is a high level language. So about low level, high level language discussed yesterday. Okay. Yes, Java is a high level language. High level language for this. Examples this, right? Java is a high level language. Okay. See, here high level language to binary code. So every high level language program has to convert into binary code. Otherwise, system cannot understand. See, C program, C++, Java, Python, these programs, system cannot understand, right? All these programs have to convert into binary code. System understandable language, binary code. System understandable language is binary code. Binary code, zeros ones format. So every program has to convert into this binary code only. So how to convert? Which one will convert here? For this interpreter or compiler? Yes, either interpreter or compiler will convert from high level language to binary code. High level language to binary code. Okay, either interpreter or compiler converts from high level language to binary code. One second. Yesterday's class. Yes. So high level language to binary. So this is our class topic. Yes, either compiler or interpreter. Okay. Yes, interpreters or compiler. Yes, to convert. So these are to convert, convert from high level language to binary code. These are to convert from high level language to binary code. Yes, now topic is about interpreter and compilers. Let us see about interpreter and compiler. Topic about interpreter and compiler. Topic about interpreter and compiler. First, let us see about interpreter. So let us see about interpreter. About the interpreter. Interpreter. Yes, about interpreter. So for interpreter, best example, Python. I am taking Python example. Okay, interpreter. For this, I am taking Python. Let us see some Python script. Very simple script. Let us write some Python script. Test.py Python script. Yes, let us take some Python script here. So D drive, super test folder. Here I'm writing some Python script. Okay, very simple script I'm writing. So I'm taking Notepad. Okay. Yes, Python application development, we have the ID, separate ID, PyCharm ID available, Visual Studio Code. That IDs we can use for Python. But actually very simple script. For very simple script, simply I'm taking just Notepad, using Notepad. D drive test folder. So here I'm using some Notepads. Yes, D drive test folder. Yes, how can you go to this? Yes, for this, we should go to command prompt. I'm using command prompt, CMD, CMD, CMD command prompt. Yes, it's a command prompt. Command prompt. Now, first of all, we should go to D drive. D colon. Yes, D drive. So D drive. Checking contents of D drive. DER. So D drive contents. See all these D drive contents. So here DER means directory. See D soft. Okay, it's a directory. So directory. So all the directories, M and Raw and all these are directories, right? Direct, they are directories. Same thing D drive. Open here, they are folders, right? D soft, fast track, yes, M and Raw, all these, right? They're folders. Folders. They're all their folders, right? Folders. Same folders, here's the directories. Same directory folder, both are same. Directory folder, both are same. See, this is called a GA, Windows GA. This is Windows GA. It's a Windows GA. Yes, this is command prompt character interface. Okay. Yes. Yes, see this. Yes. Yes. Windows is a GAOS. Windows is a GAOS. Right? Yes. GA. GA means graphical user interface. Graphical. Graphical. Graphical user interface. GA means graphical user interface. Graphical user interface. Graphical user interface. So Windows is a GA. GA. Okay. Next, this is called, yeah, this is a command prompt. It's a character interface. Character user interface. CA. So CA or CLI. CLI. Right? CA. CA means character user interface. Character. Character user interface. Character user interface. CA means character user interface. Next, here it says CLI. CLI means command line interface. Yes, command line. Command line interface. Command line interface. Command line interface. CA means character user interface. CLI command line interface, right? Okay. So as for GA, it's a folder. In GA, these are all folders. Calling as folder. Okay. So you can folder and directory both are same. Folder directory, folder directory, folder and directory both are same. No difference. Both are same. Both are same. Both are same, right? Only terminology difference. Only terminology. Yes, in GA calling as folder. In GA it's a folder. In GA it's a folder. It's a folder. Yes, in character interface directory. Both are same. Both are same. Both are same, right? Both are same. Okay, fine. So next step. Now we are in D drive. D drive. Yes. D drive in D drive test folder. From D drive go to test folder. From D drive we should go to test folder. So test directory. Directory. So changing directory. CD. Change of directory. CD test changed. Right? Not check it. CLS clear screen. DR check it. Test folder. Nothing. Zero files. Test directory. Yes. Directory of test. Yes. Zero files. See this here don't have any, right? Empty. I'm repeating once again. So D drive test folder. I'm using test folder. Okay, test folder. Yes, to write notepad. Yes, that's a Python scripting. Yes, I'm repeating. So first command prompt CMD open command prompt of opening command prompt. Now we are at the C users del mnr. Now from this we should go to D drive. So D colon D drive, right? D drive. Check the contents. Checking contents. DER contents, right? Checking contents. Yes, in this there is a test directory. Test directory. So CD change after CD test change. Change, right? CD test changed. Changed. CLS clear screen. We are at test directory. Test the contents. Yes, directory of test, nothing, zero files, empty. It's empty. Now here I'm writing some simple Python script. Okay, Python script using notepads. Yes, notepads, notepads, test.py, test.py, notepad test.py. Yes, cannot find file test.py. Do you want to get yes? Yes, here I am writing simple Python script here. A is equal to 10. Yes, B is equal to 20. Next, C equal to A plus B. Yes, print, yes, addition is equal to comma C. So displaying C value, addition. So adding two numbers. Next, subtracting two numbers, multiplication of two numbers. C equal to A minus B. Yes, next, subtraction. Subtraction. Yes, C next C equal to A into B. Yes, addition, subtraction, then multiplication. See, in Python, variable declaration is not necessary. Okay, so A equal to 10, B could directly can use it. Python is a dynamically typed. So A initially using for 10, same variable you can use for next time string also. Next time for float real numbers. Next time for boolean, dynamically typed. Same variable you can use for different types. So variable declaration is not necessary. The declaration is not necessary. So A equal to 10, B equal to 20, C equal to A plus B. So addition. Next, C equal to A minus B. Subtraction, C equal to A into B multiply. So this is very simple script. Okay. Yes. Now, so this is script, right? This script. Yes. TR. Check it. See this. Test.py, right? Test.py. Okay. So DR, the test.py, this script. Okay. So we can run directly here. So need not check in errors here. Suppose if it is C programming, first compilation checking for errors. In C programming, first of all, compilation checking for errors. Okay, if no errors, then executing. That is C programming. But in Python, what happens here? Yes, direct execution. Yes, no errors checking, nothing here. No compilation process. Directly execution. Direct execution. Test.py series. Addition, subtraction, multiplication, right? No errors. Everything is fine. Addition equal 30, subtraction equal minus 10, multiplication equal 200, right? Suppose any error comes, what happens here? Suppose any something wrong here. Something wrong, what happens? That is something wrong. See, command prompt, it will maintain the history, commands history. Yes, using up arrow you can get the previous commands. I'm getting previous commands. Okay, it will maintain the history. See, up arrow key, down arrow key like this. Up arrow key, down arrow key. Now up arrow key. So that notepad test.py. Okay. Now suppose some mistakes. Here comma missing. For example, here bracket missing. Suppose here double quotation missing. Totally there are three errors. What happens? Three errors. Then what happens? Let us see. There are three errors in this. Now what happens? Let us see. Now run it here Python test.py. Yes, run it. See, line number 8, right? Actually, there are three errors, but showing only line number 8 is not showing all the errors. Okay, actually, there are three errors. There are three mistakes, but showing only one error. It is showing only one error. Only one error. What's the reason? Yes, let me explain. So here, how that interpreter is working. Let me explain clearly. Actually, there are three errors, but showing only one error. Reason, let me explain. Yes, your Python script. Python script. First statement, suppose A equal to 10. Yes. B equal to 20. C equal to A plus B. Next, print addition. Next, C equal to A minus B statement. Yes, print subtraction. Yes, next, C equal to A into B. Print multiplication. So let us, this is your Python script. Python script. So how it's working, how that interpreter is working here. So first of all, interpreter checking first line. If it is correct, then it goes to next line. Next line also correct. Next statement also correct. Next quote, next statement. Suppose next statement something wrong, simply stops. Yes, if any error comes, interpreter stops. It going to go to next line, next line like this. So you can interpreter working is like this. Interpreter. So interpreter working is like this. Okay, interpreter checking line will first line checking. If it is correct, then checking next line. If it is correct, then checking next line. Something wrong, it stops. Something wrong, it stops. It won't go to next statements. It won't check next statement. Something wrong, stops. See, let us see practically. See here now. So this is showing first error, right? See, in the script there are three errors. Here mistake is there. Here also mistake. Here also mistake, right? There are three errors, but showing only this error shown here. Let us correct this error. Comma missing. Correction is done. Save. Save. After saving, now I'm running this is that Python. I'm running. See this. Now next error showing, right? Next one. Next one. Right? Next one. 12th line error. So that means if any error comes, interpreter stops. So interpreter checking line by line. Okay, interpreter checking line by line. Line by line, first line correct, next good, next line. Next line correct, next good, next line. Next line something wrong, simply stops. Simply stops. It won't check for rest of the codes. So stopping here only. Stopping here only. Any error comes, interpreter stops. Okay, it shows only one error. It shows only one error. Okay, right? Now you get 12th line error. 12th line error. Now let us correct this mistake here. 12th line. So 12th line here, bracket missing, right? Bracket missing. Yes, save it. Save it. Next again, try to run it here. Try to run it. Yes, now 16th line error, right? 16th line error. Also, only one error showing, not all the errors, only one error. Any error comes, simply stops. The syntax error. Syntax error. Okay, right? Yes, next error. So here this is next mistake. Here W code is missing. Save it. Save it. Next, run it here. Yes, done. Complete it. Complete it. Complete it. Yes, next here. Suppose here checking line by line. First line checking. If no errors. Next line checking. If no errors. Next line. Suppose something wrong. Some syntax mistakes. Stops. Simply stops. Suppose if no error, then how it's working? This also let us see. Suppose if no error, suppose next statement is correct. So next is also correct. So top to bottom, everything is fine. 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 Then what happens here? Every statement is correct. Then now, yes, executing statements. How this is? Again line by line. So first line, it converts the first line to binary format, zeros ones format. So this line will be given to yes processor. So processor taking that codes, generating output, generating outputs, generating outputs. After that, next second line. Okay. Now it converts second line into binary format, second line into binary format, zeros ones format, and given to process. So line by line. So execution also line by line, generating outputs, generating outputs. After that, next it goes next line. A zeros ones format converting and given to processor. So given to processor, yes, generating output, right? So this execution also line by line. Yes. So here interpreter, not only Python interpreter, all interpreter, different language, different interpreters. Different language interpreters, right? Interpreter based language. Yes, any interpreter based language working like this only. Like Python, HTML, Linux shell scripting, Perl scripting, PHP, all interpreter based language. Interpreter based language working like this. Okay. Yes, suppose if everything, yes, checking line by line, first line checking, next line checking, next line checking, next line checking. Suppose something wrong stops, any error stops. Suppose if no errors, yes, execution of line by line. So first line converts into binary code, generating output. Next line converts into binary format, given to processor, then executing, generating output. Next line converting to binary format, yes, given to processor, generating output, right? So this is working of interpreter. It's working of interpreter, right? Now let us see compiler example. Compiler. Yes, compiler. Let us see about compiler. Compiler example. For compiler, I am taking C program. For compiler, I am taking C program. Compiler. Yes, C is a compiler based compiler. Okay. Yes, C language. I am taking C language, C program. Just I am taking C program. C program. C program. Support test.c. Test.c. Yes, how compiler is working. Yes, let us see about compiler. Yes, how compiler is working here. About compiler. Yes, C program. For compiler, I'm taking C program. Yes, let me start C IDE. Yeah, Turbo C. It's a C language IDE. C program. Same example in C language developing here. Same example. Same example. Yes, hash includes std io.h. Hash include std io.h. Next, hash includes conview.h. Next, white main function starting ending main starting ending. Yes, suppose int a variable a, next int b, next int c. Same example, addition, subtraction, multiplication. CLR, SCR to clear the screen. CLR, SCR. Yes, it's a predefined function from conview.h. Okay. Now, first number A. So printf, printf. Yes, in C language is a printf. In Python is a printf. Java println. So printf. Enter first number. Enter first number. Enter first number. So enter first number. Enter first number. Reading first number. Scanf. Scanf to read data from the keyboard. Yes, personal D. Yes, personal D. Comma ampersand. Ampersand A. Reading value of A. Right. Next printf. Printf. Enter second number. Enter. Enter second number. Enter second number. Enter second number. Enter second number. Second number. Scanf. Scanf. Yes. Personal D. Yes. Ampersand of B. Right. Yes. So your first number. Yes. So ABC declared here. So first number. Second number. Now. Yes. Addition C equal to A plus B. C equal to A plus B. C equal to A plus B. Okay. Right. Yes. Printf. Printf. Display the addition value. Yes. Addition. Slash and next line. Yes. Addition. Yes. Addition is equal to, so additional value, comma C, display the C value. Next, C equal to A minus B, A minus B, A minus B, subtraction. So printf slash n, that will take next line, subtraction, 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 displaying C value, subtraction, right? Next, C equal to A into B, A into B, C equal to A into B, C equal to A into B. Yes, printf slash and multiplication, multiplication. Yes, displaying C well, right? That's it here. Okay. Then finally get CH. To see the output, get CH. So this is C program, right? Yes, no. So first of all, let me save this one. Save it. Save it. Support test.cpp. Saved. Yes, C++ compile using for C program also. Okay. Yes, that C++ compile using for C also. Now let us compile it. So file, save it, saved. Okay, saved. 1 second. Yes, where this file saved? Let me show that. Yes, location C drive, TC in this saved bin folder here, test.cpp, not bin folder, bin. Yeah, test.cpp here saved. See, today, 24th. So 8:29, just now saved, right? Just now saved. Now I'm compiling, compiled, success. No errors, right? No errors. No errors. Yes. See, compile, success. No errors. Now run it. Yes, 1 second. So compilation, just a compilation process. Compile success, no errors. See, warning 0, error 0. Press any key. Press any key. No, run it. Run it. Yes, enter first number 10, second number 20. See this. Addition, subtraction, multiplication. No output. 1 second. C equal to A plus B. C equal to A minus B. Why not dispatch? Sorry. Yes, addition here personal D missing. So personal D. So personal D. Yes, save it. Now run it. Compile success, no error. Run it. First number 10, second number 20. Sees addition equal 30, subtraction minus 10, multiplication 200. So this is C programming. Same exam C programming. Suppose here any mistakes. What happens? Let us see. Suppose some mistakes. Suppose here semicolon missing. Semicolon missing. Suppose here some bracket missing. Okay. Suppose here comma missing. Suppose here bracket missing. Okay. Yes. Here some semicolon missing. There are some mistakes. Here comma missing. Okay. Yes. Suppose here at the end here it's a bracket missing. There's something missing. Statements missing. Right. Now save it. Save. Saved. Saved overwrite. Yes. So once program modified, we have to save it on recompilation. Compile. See this errors. Totally 8 errors. Totally 8 errors. Press any key. Totally 8 errors. See this. Look at the bottom. 10th line error. Test.cpp 10th line error. 12th line error. 16th line error. 21st line error. 23rd line error. 27th line error. 29th line error. 35 line. So all the errors from top to bottom. All the errors from top to bottom. All errors from top to bottom. All errors from top to bottom. So let me explain how compile is working here. So compiler, yes. In case of interpreter, what happens here? First line checking, next line checking. If any error comes, simply stops. Any error, interpreter stops. Interpreter shows only one error. Interpreter shows only one error. Only one error. Yes, when come to compiler, what happens here? So compiler checking whole code from top to bottom. It checks whole code. Checking first line. Yes, if it is correct. If it is correct, yes, if it is correct, then checking next line. Yes, first line checking. So checking first line. If it is correct, then checks the next line. Next line also correct. Next line. Suppose next line something wrong here. Compiler shows error at some line. Error at some third line. After that checking next line. Yes, even error comes, it goes next line also. Even error comes, it goes next line also. But interpreter stops. Interpreter stops. Any error comes, interpreter stops. It won't go to next line. Okay, right? Checking for next line. So even error comes, it goes to next line, next statement, next statement. So next, suppose something wrong, error at some line here. So next statement checking. So next statement checking. Like this top to bottom. Compiler checks the whole code from top to bottom, shows all the errors. Compiler checks whole code from top to bottom and shows all the errors, but interpreter checking line by line, first line checking, next line checking, next line. Suppose something wrong, stops. Something wrong, stops. Something wrong, stops. It shows only one error. Something wrong, stops. It shows only, yes, interpreter shows only one error. It stops there only. But compile is not like that. Compile is checking whole program from top to bottom. It shows all the errors. See, even error getting, it goes next line also, next line also, next line. Suppose one more error. Yes, they go to next line, next line. Yes, checking whole code from top to bottom. Compiler checks whole code. Compiler checks whole code from top to bottom and shows all the errors. Shows all the errors. Interpreter is only one error. Compiler shows all the errors. Yes, now let us correct all the mistakes here. Yes, there are that mistakes. Let me correct all the mistakes here. Yes, all that mistakes. All that mistakes. So here bracket missing. Okay. Yes, all the errors from top to bottom. See semicolon missing here. Okay. Yes. Suppose here semicolon missing. Yes. Right. Some mistakes correction is done. So here comma. Right. Now save it again. Once program modified, we should save it. Save it. Yes. Overwrite. Yes. No recompilation. Yes. Again still three more errors. Still three more errors. Three errors. Right. Three errors. Press any key. Now three errors. So the statement is error. So the statement is error. Next here scan of here comma missing. So here it's error. Okay. Yes. Now save it. Save it. Say yes. Overwrite. Now recompile. Still one more error. One more error, right? One more error. Press any key. So one more error. So here comma missing, right? Comma missing. Okay, right? Now save it again. Saved. Save. Overwrite. Yes. Compile. Yes. Success. 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 No errors. No run it. Yes. Enter first number. Yes. Enter next number. So getting addition, subtraction, multiplication, right? That's it. So here now this, if no errors, what happens? Let us see. Suppose if no errors in the program, yes, here if no errors, what happens? Let us see. Suppose here compiler, this interpreter, yes, interpreter, no errors. No, if in interpreter case, no errors, line variant converting and generating output. Line variant converting, generating output. Line variant converting into binary code, generating outputs. But compiler is not like that here. So compiler, what happens here? Suppose no errors, everything is fine. Checking top to bottom. Yes, whole code. Compiler checks the whole code from top to bottom. Whole code from top to bottom. Suppose no errors. Everything is fine. Yes, if everything is fine. If everything is fine, then compiler, yes, compiler it opens another file. It's not line variant. Compiler is not line variant. It's not line variant. It's not line variant. Okay. Yes. What happens here? Compiler opens another file. Simply compiler opens this another file. Compiler opens another file like this. After opening another file, this code means your C program code. This code called a source code. This is source code. This source code. Now compiler converts this whole code into binary format and write to this file. Zeros ones format. Zeros ones format. Whole code converts into binary format and write to some result file. Write into this file. Write into this file. So compiler checks whole code from top to bottom. If no errors, then write to another file. This file is a exe file. This is called as exe file, test.exe file. That exe file creates. Test.exe. .exe file creates. Here compiler checks whole code from top to bottom. Compiler checks whole code from top to bottom. Suppose if no errors, whole code convert into binary format, write to another file. This file is a exe file. Exe means executable file. Exe file generates. After generating exe file, now this exe file given to processor. Exe file given to processor. So processor taking that exe file at a time executes generating output here, right? So compiler checks the whole code from top to bottom and shows all the errors. Suppose if no errors, this code means that your source code, this is source, your source C program source. This converting into, so this code, your C program source converting into binary format, write to another file. Another file, this file is called exe file. So test.exe file creates. After creating exe file, this exe file given to processor. So processor taking that exe file executes. See this, executes and getting out. So behind of this program, see here, test.exe file created. Application.exe file created. Let me show once again. Just I'm deleting that file. Yes, all these the related files I'm deleting. See test.cpp. Okay. Yes, compile. Yes, success. no errors, success, no errors. Now I am running. So when I try to run it here, before going to run, it will create one exe file. Here, try to observe here, exe file. Yes, run it. See that? The test.exe will just created now. The exe file created. So enter first number 10, enter second number 20. Yes, result got it right. That's it. Yes. So finally exe file generated. So finally exe file generated. So that exe file created and executed. Exe file created and executed. See, in case of Python, what happened here? In case of Python, in case of Python, in case of Python, interpreter based language, test.py, test.py. Yes, what test.py, the test.script, test script. Yes, notepad, notepad test. Sorry, notepad. See test.py. So the script, right? So this is your script. So the script executing directly. No exe file here. Yes, here that script executing directly here. Test.py. Your script, the source code. So this is called a source code here. This is called a source code. This is source. This is source. It's a source code. That source code executing directly here. That source code executing directly. Okay. Source code executing directly here. Source code executing directly. Right? Executed directly. No exe file. That interpreter not generate any exe file here. Directly source code executed. So this is a difference. Okay. So this is a difference here. Compile interpreter difference. Now tell me guys, what is the main difference observed between interpreter and compiler? Anyone can ask this question. What do you observe the difference here? See,
Interpreter, we are doing line by line step. If
okay,
one first line is error, it will not go to execute second line. We can
okay.
stop the in
Next compile.
compilation at a time it will check entire. Suppose 10
Okay.
lines errors are there, it will show 10 lines
Yes.
errors in there. That is the
That's a
main difference.
that is that is not a main. That is basic difference. Next main difference is there. Tell me what is observed in this explanation here. So this is the interpreter page. Expand here, compile here, expand. Here interpreter expands. Here compile expand. So what is observed here in these two explanation? What is so this is the interpreter expand here. Next here compile expand. So what's the difference observed here? Something observed.
.exe file not
This
generated.
dot exe file. Exact. That is X difference. Okay. Dot exe file is difference. Yes. This one no one will tell you. Okay. Most of the trainers simply they explain about interpreter line by line, checking line by line execution, compile a whole program at a time. Only those 2 points. But actually, it's a exe file generates. Exe file. Exe file is a difference. So compiler, if it is compiler based, exe file generates, interpreter based don't have exe file. That is actual main difference. So main difference here exe. So compiler generates exe file, interpreter won't generate exe file. Okay, let me explain points with the differences. Compiler, yes, interpreter. Yes, interpreter versus compiler. The differences, let us see. Yes, let me explain clearly points wise. Differences. Yes, differences. Yes, interpreter versus compiler, the differences. See interpreter, next compiler, interpreter, compiler. See interpreter, first one. Yes, it checks the codes. Checks the codes line by line. Checks the codes line by line. Checks the code line by line. Yes, interpreter checks the code line by line. Compiler, yes, it checks whole code from top to bottom. The whole code, it checks whole code from top to bottom, from top to bottom, from top to bottom, from top to bottom. It checks whole code from top to bottom. See, interpreter checks the code, interpreter checks the code line by line, compiler checks whole code from top to bottom, right? Yes, next step. Even execution also line by line. Yes, it converts line by line, then giving output to. Okay, yes, yes, it executes code. It executes code. Yes, first line converting, then giving output. Second line converting, giving output. Third line converting, giving output. It executes code line by line. Line by line, executes code line by line. Line by line, it executes code line by line. Compiler, exe file creating, right? Exe file creating and executing at once, right? Okay. So here it executes at a time. It executes whole code. It executes, it executes whole code, whole code at a time. At a time, right? At a time, whole code at a time. It executes whole code at a time. It executes whole code at a time. So interpreter, it executes code line by line. Yes, compiler, it executes whole code at a time, right? Next here, interpreter. Yes, if any error comes, if any error, okay, if any error, yes, it stops. It stops. It stops. It won't check next lines here. It yes, it won't check. Yes, it won't check. It won't check next statements. It won't check next statements. It won't check next statements. Next statements, right? Next statements. Next statement, right? Yes, compiler checks. It checks whole code from top to bottom, right? It checks whole code. It checks whole code from top to bottom. It checks whole code from top to bottom. Yes. Interpreter, if any error stops here, it won't check next statements. Next statement. But yes, compiler, it checks whole code from top to bottom. It checks whole code from top to bottom. Yes. If any error, yes, interpreter stops. So it shows only one error. 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 It shows only one error, right? Yes, compiler. It shows all the errors from top to bottom. It shows all errors. All errors from top to bottom, from top to bottom, from top to bottom. All errors from top to bottom, right? From top to bottom. It shows all errors from top to bottom, right? Next, interpreter, no exe file. It does not generate exe. It does not generate, does not generate, does not generate exe file. It does not generate exe file. Yes, interpreter, it does not generate exe file. Compiler, it generates exe file. It generates one exe file and executes. It generates exe file and executes. It generates exe file and executes, right? Executes. Executes, right? Okay. Yes, next, in case of interpreter based interpreter, just source code executing directly, right? It executes source code directly. The source code executing that test.py, the script executing directly. That source code. So whatever the program we are writing, that is source code. Our programs are called a source code. Yes, so interpreter executes source code directly. It executes source code directly. It executes source code directly. It executes source code directly. But compiler what happens here? It converts in exe formats. Compiler converts source code to exe formats, converting source code to exe file and executes exe file. Yes, it executes exe file. It executes exe file. It executes exe file. So next difference here, interpreter. Yes, interpreter based these languages, interpreter based these languages are called as scripting languages. Scripting languages, scripting languages. Interpreter based languages are scripting languages. Interpreter based is scripting language. Compiler based is what here? Calling as what? Compiler based is a interpreter based is scripting language. Compiler based is a programming language. So these are called as called as programming language. Programming. They're called as programming language. Programming language. Okay, scripting language and programming language. Scripting and programming. Scripting. Interpreter based is a scripting language. Compiler based is a programming language. Scripting language and programming language. Scripting language and programming language. Right? Next here, yes, interpreter examples. Yes, interpreter based language examples. What is example of interpreter based language? Just now discussed. Best example? Just now discussed. Interpreter based language example, Python, right? Python is a interpreter based language. Any other language interpreter based? Python. Next,
JavaScript.
HTML is a interpreter based language, right? HTML. So HTML, hypertext markup language. See, HTML is a browser understandable language. Okay. So browser is an interpreter for the HTML. HTML is a browser understandable language. So HTML is executing with the browser. Browser is an interpreter. JavaScript also same. JavaScript also browser understandable language. JavaScript also interpreter based. JavaScript is also browser understandable language. JavaScript is different. Java is different. JavaScript is not Java. JavaScript is not Java. Java different. JavaScript different. See JavaScript. Yes, where the JavaScript comes, where Java comes. JavaScript is a front end. JavaScript is a front end language. Next, Java is a back end language. JavaScript using at the client side for client side validations. JavaScript is using at the client side for client side validations. Java using at the server side to perform server side transactions like the working with database and all server side business logic. Java is to develop the server side business logic. Server side business logic. JavaScript is client side working for client side validations. So JavaScript working with the browser environment. Java working with the JVM environment. That is different. This is different. So JavaScript is not a Java. Completely different. Completely different. So JavaScript is a yes, yes, interpreter based language. JavaScript is a yes, interpreter. Here browser is an interpreter. For HTML, JavaScript browser is an interpreter. So these two things executes in the browser environment. Right. Next, PHP scripting. So PHP has its own interpreter. Perl scripting. Perl has its own interpreter. Next, Linux shell scripting. It has one interpreter, right? So examples of scripting language. Okay, next. Yes, interpreter based language. These are interpreter based language. These all the interpreter based. Compiler based. Compiler based examples. Examples C and
C,
C++. C and C++. Next, dot .NET.
Java.
.NET C Sharp. .NET C Sharp is also compiler based, right? So these are interpreter based and compiler based examples. So interpreter based examples, compiler based examples. Finally, conclusion here. Yes, interpreter. Yes, interpreter. Yes, interpreter. Sorry, interpreter. Yes, interpreter based language don't have EX. Simple conclusion here. Interpreter based language don't have exe file, don't have exe file. This is simple. Okay, finally conclusion, interpreter based language don't have exe file. Any interpreter based language don't have exe file. Python no exe file, HTML files no exe, JavaScript no exe file, PHP Perl scripting, yes, all these things here no exe files. Here don't have exe files. Okay, yes, in case of compiler based. So finally exe file generates. Finally, yes, every program finally converts in exe format. Every program finally converts in exe file. So here, so every program finally converts into exe file, and executes, right? Executes, right? And executes. That's it. Okay. So interpreter based language don't have exe file. Directly source code executes. But compiler based, every program finally converts in exe format, exe file, then executes, right? Fine. So this is difference. Interpreter and compiler. Fine. Okay. So we are discussing about many things here. So Python, C, C++, and all this, right? Now where is Java? Yes, Java not discussed yet, right? Now let us see about Java. Java, is it compiler based or interpreter based? Yes, anyone idea about Java? Yes, Java.
Compiler based.
Compiler based.
Compiler based.
Yes, Java is a compiler based. Yes. Everyone saying same thing? Anything different answer? Java compiler based, interpreter based. Java compiler based, interpreter based. Any answers? Any other answers? Yeah. So this guy is saying that compiler based. Any other answers? Of course, I'll explain. Any other answers? Java compiler based, interpreter based. Okay. Let me explain. I'll explain about Java. Finally you decide it. I'll explain Java. You decide it. Okay. Yes. Let us see about Java. 1 second. So today topic, it's here in document. So that running notes is not necessary. For every topic, I have prepared the documentation. Yes, I have documented. So very clear documentation is there. Very clear documentation. So running notes is not necessary. So this is for you only. Okay. Yes, today we are giving drive access to all paid students. So we are paid for all of them. We are giving yes recordings access and this document also sharing. Today I'll do it. Today I'll talk to online team. Whoever paid for all of these things, this document will be sharing. And also recordings drive access will be given. Recordings and this document will be shared with you. Yes. So today topic difference between compiler and interpreter. See this interpreter compiler. See all this. Whatever points it's that 9 points, right? Same thing here is there. Same that 9 points. I have prepared in document. So running notes is not necessary, just to follow document. Just to follow document. Okay, follow documents. Now about Java. Let us say about Java. About Java. Say about Java. Yes. See about let us say about Java. Java compiler based, interpreter based. Let me explain about Java. I'll show practically. Then finally you decide it. Finally you decide it. Okay. See except Java. Except Java. Except Java. In other language, what happens? Let me explain. In other language, means like C language or C++, Python. In other language, what happens here? Yes, your source codes, program source codes, simply source codes. You see, this is called a source. This is source. So, what are the programs we are writing? These programs are source. This is source. So, this is source code. This is source code. Source code. Yes, Python. Yeah, this is Python source code. That English language program. Our code is a source code. What are the program we are writing? So what are the program we are writing here? That is source code. This is source code. Now this is Python source. Python source. This is C program source. C program source, right? Now what happens here? Yes, except Java in other language, source codes directly converts into binary codes. Source code to binary code. So initial source code converts into binary code. That binary code given to processor. So processor is taking that binary code and generating output simply. That's it here. Okay. Source code to binary code. Converting source code to binary codes. Okay. Maybe interpreter, maybe compile. Suppose if it is Python, in Python, yes, interpreter converts the source code to binary code, then executing. If it is C language, in C language, source code to binary code by the compiler. C++ are the same compiler. So either interpreter or compiler. In Python, interpreter working. In C language, compiler working. C++ also compiler working. So for HTML, so interpreter working. Interpreter converting source code to binary code, then giving output. Okay. Now in Java, what happens? Let us say about Java. So in Java, same thing. Java, what happens? Java codes. Yes, in Java, what happens here? Source codes. So first of all, Java code, simply converting into byte code. Java code converting into byte code. Java code converting into byte codes. Java code converts into byte codes. Okay, so that byte code next converts into binary format. Binary codes. Byte code to binary code. That binary code given to processor. Binary code given to processor. Binary code given to processor. Finally generating output. Finally generating outputs. Finally getting output, right? Yes, source code to byte code to binary code. First of all, so is there two steps? Yes, converting in two steps here. So first is source code converts to byte code format to binary codes. Yes, here in Java byte code introduced. So some intermediate code. So byte code introduced. So why this intermediate code introduced in Java? So byte code was introduced. Byte code was introduced to make Java as independent of platform. To make Java as an independent of platform. Java is an independent of platform. To make it as independent of platform. Yes, how Java made us independent of platform? We'll discuss next. I will explain. It's a tomorrow class. Java is an independent of platform. In tomorrow class, I'll explain it. Yes, tomorrow class, very interesting class. Wonderful class you can see tomorrow. Okay. Yes. Java is an independent platform. Reason tomorrow I'll explain here. So here bytecode. So here bytecode. Bytecode was introduced. Bytecode was introduced to make the Java as independent platform. Now here source code to bytecode. Here source code to bytecode conversion. So this is by the compiler, Java compiler. So Java. So this is by the Java. This part is by the Java compiler. Java compiler. Right? So next what? Bytecode to binary code. Second step. Second step by the Java interpreter. Second step by the Java interpreter. Java interpreter. Second step by the Java interpreter. Right? Yes. Let me show practically. Let us see practically. Compiler. So first step is compiler. Next step is interpreter. Let me show that. Practically, let us see. So for this, I'm taking some test.java. Test.java is a source code. Test.java source code. Test.java. Let us take some Java program. Java program. D drive. Test folder. Okay, let me delete that. Yes. Refresh. Now here I'm writing some Java program. Simple Java program. For this, I'm using Notepad. Actually, for Java program, everyday class expansion using Eclipse. I'll be using Eclipse. Even development or CRT is Eclipse compulsory. No Notepad. In real-time application, don't have any Notepad concept. Don't have Notepad. Simply you have to use Eclipse on Eclipse IDE. Eclipse IDE. Don't have Notepad concept. So just only one example I'm explaining Notepad. Okay, I'm taking Notepad. Very simple program. I'm taking Notepad. Okay, Notepad. Okay. Yes. Now, so D drive. So at the command prompts, CMD. So command prompts. Open command prompts. Yes, command prompts. Yes, command prompts. So here go to D drive. D colon will take to D drive. Check the contents DER, right? Contents DER. See that here test, right? Test is a directory. Now we should go to test directory. Test directory. We should go to test directory. So test directory. CLS, clear the screen. Not D drive. Test directory. Now we should change to test directory. How can you change to test directory here? What's a command to change to test directory here? Already explained. What is command? What's a command? What's a command to change to test directory? Changing directory. Yes, I'm saying already. Changing directory. What's a command? CD command. CD. Change of directory. CD test. Change of directory. Previously already discussed. CD test. CD test. Change rate. Yes, CLS, clear screen, now check it here, DR, nothing, empty, zero files. Now let us write one Java program. Let us write one Java program. Notepad, test.java, notepad test.java, notepad test.java. Yes, open. Yes, do you want to create new file? Yes. Now let us write simple program. Yes, simple Java program, public class test. See, our topic is about interpreter and compilers, not actual Java program. Actual Java program, yes, tomorrow going to start. Tomorrow I'll write, yes, I'll do the first application. Java setup and application development, all that tomorrow we'll discuss. Public class test. Public class test. Yes, public static void main. Yes, string. Yes, fox string area function. So main method. Starting, ending, yes, this system dot out dot println. So here println, here it's a hello world, right? Hello world. Save it. Saved. Yes, dir. See this test.java file just now created 9 o'clock 4 948. So this is see 24 for today. So that's timestamp, today timestamp, right? Yes. Now, yes, after writing this here, next you have to come with Java C, means Java compiler. Now I am compiling test.java, right? Compile, no error, no error, no error. Yes, if no error, get generated one dot class file. If you don't have error, that's what's happening. No error generating dot class file. Right? So here the dot class file generated. So this dot class file is byte code. Test.java is a source code. Source code. So you get dot class file is a byte code file, not binary format byte code. What is byte code? I'll explain. Yes, once Java programming started, I'll explain about bytecode also. Once Java programming started, I'll explain bytecodes. Okay. Now dot class file generated. So it's a bytecode file. Okay. So Java C, Java compiler, yes, checking all the errors. If no errors, generating dot class file. Generating dot class file. So dot class file generated. Now this is compiler, Java compiler. Okay. Now what happened here? Source code test.java. This is given to Java C, Java compiler, Java compiler, Java compiler taking that source code, yes, checking all the errors from top to bottom. If no errors, generating tested dot class, tested dot class, dot class a byte code. It's a byte code file. It's a byte code file. It's a byte code. Byte code generates. It generates byte code. Generates byte code. Right now, byte code is ready. After generating bytecode, now execution. Java test. Java test. Java test, right? Yes, enter key. That hello world got it, right? Java test. Hello world got it output, right? Now what is Java? See here, Java C means it's a compiler. Compiler checking all the errors. If no errors, generating dot class file. After generating dot class file, this dot class file executing, right? Java means now it's the interpreter. Now interpreter will come to picture. Java interpreter. Java interpreter taking test dot class file, taking test dot class file, line by line converting to binary formats and generating output like this. Now here interpreter working. So program execution by the interpreter. So errors checking by the Java compiler, errors by the compiler, but program execution by the interpreter. Program execution by the interpreter. Okay, right? Now dot class file. Dot class file given to Java interpreter. Java interpreter, right? Java interpreter. Java interpreter. Okay. So interpreter taking the dot class file here. Yes, converting into binary format simply. Converting into binary format, binary code. It converts into binary line by line. Java interpreter taking dot class file. Yes, dot see, this dot class file taking with Java interpreter and converting into binary code line by line. Line by line. Yes, that code given to processor, that will be given to processor. So processor. So processor will take that code, simply executes and generates output simply. That's it here. Okay. So what is happening here? Source code to bytecode by the Java compiler. So what happens here? Okay. So you can Java errors, errors checking by the Java, errors checking by the compiler, errors checking by the compiler, errors checking by the compiler, errors checking by the Java compiler, errors checking by the Java compiler. Suppose if no errors, if no errors, if no errors, then yes, it generates dot class file. It generates dot class file. Dot class file, it generates dot class file. So errors checking by the Java compiler. Source code to bytecode. So Java compiler checking for all the errors. If no errors, source code converting to bytecode. So bytecode. So generating the dot class file, generating dot class file. Okay. Now the dot class file, yes, taken by the interpreter and converts into binary code. So dot plus bytecode to binary code by the Java interpreter. Okay, right? Then executes, converting into binary formats and given to process generating output, right? So here errors checking by the Java compiler. If no errors, generating dot class file here. Okay, right? Yes. Next program dot class file. Dot class file execution. Yes, execution by the interpreter, execution by the interpreter, right? Interpreter. So execution by the interpreter. Okay, execution by the interpreter, right? So what is happening here? So here two stages is working in two stages. So first stage by the compiler, next by the interpreter, right? So these two things are involving, compiler and interpreter involving. Yes, for the Java program, errors checking by the compiler, execution by the interpreter. So these two things are involving in the Java. Suppose if it is C programming, in C programming only compiler converts into, yes, source code, errors checking by the compiler and execution also by the compiler. So error checking and execution by the compiler. Only compiler involving. Suppose Python only interpreter involving only interpreter. But in Java here, both involving compiler and interpreter. Compiler and interpreter. Now tell me, what is Java? Is it compiler based, interpreter based, or both?
Both.
Compiler based, interpreter based, both.
Both.
It's both, right? Now its concept is clear. Okay. So Java depends on both, right? Java depends on both. Both the compiler. Java depends on both compiler as well as interpreter, right? Interpreter. Java depends on both the compiler as well as interpreter. Java depends on both compiler as well as interpreter. Fine. Now some question for you guys. Some question. Can we create exe file in Java? Very simple question. Can we create exe files from Java? What do you understand? Tell me. Can we create exe file in Java? Can we create exe file in Java? See here, Java steps. So first, see Notepad. So using Notepad, Java program developed. Notepad test.java. Using Notepad. So this is Java program. Using Notepad, this program developed. Okay. So means .java file. So we got the .java file. So .java file we got it. Test.java file got it. After the compilation, Java C. So Java C test.java, right? Compiled and result is dot class file got it. Result is so .java file got it. Dot class file got it. After that, Java test run it here, right? So got the output, right? Getting output finally, right? In this process, have we observed any .exe file? See, dot class is .exe file. That is different. This is different. In these steps, in this process, have you observed any .exe file?
No.
No, right? No. Yes, no. So Java don't have exe file concept. But Java don't have exe file concept. Java is depends on both compiler and interpreter. Java don't have exe file concept here. So answer is no. Okay. So Java don't have exe file concept. Java don't have exe file. So Java don't have exe file concept. Okay. Java don't have exe file concept. So reason here, see exe file. Yes, exe file. Yes, concept eliminated from Java. So why exe file concept not there in Java? Reason, to make the Java is independent of platform. So wherever exe concept is there, that is platform dependent. Exe file concept, that is compulsory platform dependent. C language, C++, dot, they are platform dependent. Okay. Yes, suppose Python, Java. So these cases don't have exe files. If no exe file, there is independent of platform. Yes, tomorrow we'll discuss. Tomorrow about exe file, about dot class. Exe file contains exactly what? Dot class file contains what? About exe file, about dot class file. Okay, right? And then how Java made us independent of platform. Tomorrow I'll explain it. It's a wonderful topic tomorrow, no doubt. Tomorrow I'll explain very clearly. Wonderful explanation you can see. Even Google also will not provide that kind of information. Yes, very clear explanation, wonderful explanation. Don't miss tomorrow class. Okay. Yes. So exe file concept eliminated from Java. Yes, Java to make it as independent of platform. Independent of platform. To make it as independent of platform. Okay. Yes. Java don't have exe file. Exe file concept eliminated from Java to make it as independent of platform. Okay. See, in Java, everything is a dot class file. Java, yes, everything is a dot class file. Everything is a dot class file. In Java, everything is dot class file. But dot class is not exe file. So you get dot class file is not an exe file. Dot class is not an exe file. Ex is different, dot class is different. See, exe file. See, exe file is a binary code file. Exe file is a binary format. Exe file format is binary code file. Yes, and it's a system understandable language. It is a system understandable language. It's a system understandable. Exe file is a system understandable language. Directly computer can understand the exe file. Okay, so exe file is a binary code file and it's a system understandable language. What is dot class? See, dot class file is a bytecode file, not binary code. Dot class file is a bytecode file. Bytecode file, right? Dot class a bytecode file. Okay, and it's a JVM understandable language. Okay, so dot bytecode converting into binary code by the interpreter, right? Interpreter is a part of JVM. Inside the JVM, there is an interpreter. Inside the JVM, there is an interpreter. That interpreter will convert from bytecode to binary formats. Okay, means system understandable language. Converting to system understandable language. So dot class file is a bytecode file and it's a JVM understandable language. Okay, see, exe file is a binary code. Binary code means your computer directly can understand it. But when come to dot class file, it's a bytecode file that is JVM understandable language. So instead of JVM, this interpreter. That interpreter will convert bytecode to binary code. About JVM, next session I'll explain. So once Java programming started, I'll explain about JVM. Java virtual machine. How is JVM is working? Separate one session I will take on JVM. One session I will take on JVM. Okay. Yes, it's a JVM understandable language. JVM understandable language. Understandable language, right? Yes, it's JVM understandable language. Bytecode is a JVM understandable. Binary code is a, yes, your computer understandable language. Bytecode is a JVM understandable language, right? Next, one more thing. See, exe file. Yes, exe file is a platform dependent. Exe file is a platform dependent. So what is platform dependent? Tomorrow topic we'll discuss. Exe file is a platform dependent. Yes, whereas dot class file. Dot class file is a, yes, is an independent of platform. Is an independent of platform. Independent of platform. Independent of platform, right? So this is Java introduction. Java introduction. Okay. So from this class, yes. Now Java will continue here. Yes, Java started. Java introduction. Java introduced. Okay. Yes, let me show that. Today class document. See about, yes, interpreter compare differences. The difference is very clearly prepared. Very clearly prepared here. Yes, about Java. Java depends on both compiler as well as interpreter. Since Java error checking with the compiler. If no error, compiler generates dot class file. Dot class file is a bytecode file, right? So dot Java runtime by the interpreter. That means dot class file executing by the interpreter. Okay. See, Java source code to bytecode to binary code, processor then output, right? Okay. Yes. Source code to bytecode by the Java compiler. Bytecode to binary code by the Java interpreter. See, same whatever explained in document. Same thing it's already here. Okay. In document, same as this. Okay. See, it's a special document. Complete my experience. With my experience, I have prepared. See, most of the trainers, their document they will copy from the Google. So simply they will prepare on PDF and sharing with you. See, their class topics on PDFs no relation. But in our class, what are things I'm explaining, same thing as this you can see, including programs also. So what are the programs I'm explaining in the class? Same program you can see in the document here. Same program. Even single line also not missing. As this you can see. Given programs are the same. 300 programs I'll explain in the class. Same 300 programs as is prepared in the document. Suppose if any extra topic I'm explaining because of my experience, maybe recollecting, right? My job experience, if I'm recollecting, okay, I'll explain the topic. Same thing, I'll prepare in document immediately. In class itself, in class itself, I will add to documents, I'll update it. After updating, yes, I'll change the date of updating. See your document, 22nd April updated means some topic added in this document. On 22nd April means 2 days ago, some topic added. Also, whenever I'm recollecting my experience here, yes, I'll explain the class itself. After explain same topic, I'll add to document. After adding document, I'll change the date. I'll change the date. Okay, fine. Yes, after update document, I'll share it. Okay. So today, all whoever paid for all of students, this document will be shared. This document sharing here and recording search sharing. Drive access I will give you. Today I will give the drive access and document for all paid students. Right? Yes. Suppose in future any changes, I'll share again. Yes, that update document, I'll share it once again, right? Every time of updating document, I'll share it again. Okay, I'll share it again. So this is today topic. So here, so can we create exe file in Java? No, there is no concept of exe file in Java. Java, everything is dot class file. Dot class file is not an exe file. Okay, so exe file is a binary code file. It's a process understandable language. Dot class file byte code file. It is JVM understandable. So exe file is OS dependent or platform dependent. Dot class file is independent of OS. So this is about today's session topics. I hope you understand, right? Yes. Everyone is clear, right?
Yes. Yes, sir.
Any doubts, guys? Any doubts?
Yes.
Just wait for some time. Any doubts? No doubts, right? Yeah. Just a minute. Wait for 2 minutes. 1 second. Stopping.